All right, today we're going to do 7.7 checkup. It's all about similar figures, and you have to go back, I don't know, a few chapters for us. And remember when we did similar polygons and we set up a proportion problem? Because if you know the figures are similar, they are proportional, and we can solve it with a proportion problem like fraction equals fraction. We have to be careful when setting them up because we have to have the same figure. How did we set it up? The same figure information was like numerator, and the corresponding information was within the same fraction. So let's see what that all means anyway. They give us all these formulas, which is funny because we don't actually need them for this lesson. So let's do number one. Two prisms are similar. If we didn't know they were similar, we would not be able to solve this. But whenever you have two similar figures, we can set up a proportion problem. That's fraction equals fraction. And the way we set it up, there's several ways you can set it up, is we set it up so that within the numerators, we had the same figure going this way. And within the fractions, we had corresponding parts. So that's how we'll do it consistently. Now, you could reverse that, but I don't want to confuse things. So let's just keep doing what we've been doing. Since I'm solving for x, x has got to be somewhere, right? You can put it wherever you want to start with. But as soon as I put x down, I've got to have the same figure. I have to have information from that same figure. So I can either use 42 or 27 right here. Because going this way, numerator, I got to have the same figure stuff. Let's go with smaller numbers, don't you think? Sure. Larger numbers can just be a little more intimidating, I guess. Now we have to decide what corresponds with x. What's in the same spot? Well, x on this box is the height of the box, it looks like. Although it wouldn't necessarily have to be. If I chose to make the 27 by 42 rectangle the bases, then x is the height. So in its same spot over here, 4 is corresponding. And what is corresponding with 27? Of course, 9. And we have our proportion problem. Spit it out. And now we're ready to cross multiply. I don't have any space for it. So x times 9 is 9x, and that's going to be equal to the product of the other numerator and denominator combination. Let your calculator help you out, and you get 108. And then solve for x. Divide out the 9. Let the calculator help you if you need to, and you get 12. Good stuff. I'm going to let you do the next one. I'll post what number is cut off here, but you really don't need it, right? Because you're going to go x and 5 are corresponding, and then you could go 12 and 2 are corresponding, and they'll be the smaller numbers for sure. Because if 8, well, you can tell it's 40 something for one thing, and 12 is smaller than 40 anything. Anyway, you're going to do that one. Let's try another. It's all a bunch of the same. It's all similar figures. It's all proportion problem. But I'll just do one more to make sure we know what we're doing. These are similar cylinders that are oblique. We're going to set up a proportion problem. We've got to use x, so I'm going to put it, you can put it anywhere you want. It really doesn't matter where you put it. I'm just being crazy and putting it there. Doesn't matter. But the minute that's in place, I've got to have the same figure stuff here corresponding there. So what's corresponding to x in the other figure? That's 12. What information's in the same figure? That's 10. What corresponds with 10? 3. You could have done it, depends where you start to set up. It could have been a little different. Cross multiply, we're going to end up with 3x equals 120. Divide out 3, and we barely have space for 40. X is 40. They're all the same. There's absolutely nothing. And again, things are cut off a little bit here, but we have all the information we need. We have the height of this, the height, and we have corresponding measurements there. All right, number 7. This is new. It says the two pyramids are similar And the ratio between the lengths of their edges is a 3-to-4 ratio. So the smaller figure has an edge that's 3, and the larger figure has an edge that is 4. What is the ratio of their volumes? Well, it's not too complicated. I'm just going to tell you the rule. If we have their ratio, that is their linear measurement, like an edge is linear. It's just from this point to that point. To get the volume, we would have to cube it, both of them. So 3 cubed is 27, and 4 cubed, you could use your calculator. Let's see, how do we cube 4, just in case someone isn't up to speed on it. We'll go 4 caret 3 power 3, that's cubed, is 64. So the ratio is 27 to 64 for volume. I didn't check. Sometimes they might start you off with volume, the volume ratio, not a linear. This one is the radii. So the radii is a linear measurement. It's from this point to that point. So it's going to be the same thing there. You're trying to find volume. You're going to cube the 4, cube the 7. You do have to be careful though, because sometimes they'll give you the volume ratio. And that's the cubed version. So to go backwards to get to the linear, you would cube root it. But I'm looking carefully. We have 2 prisms, similar ratio between the lengths of their edges. Again, their edges, that's from here to there, from point to point. So it's a 2-to-5, that's linear. Now we want the ratio of their area. If you were in class with me, I'd make you guess, and I bet you'd be right, because if it's area, you're going to square it. So it's a 4-to-25 ratio for the area. And I just should double check. I'm going to have you do 10 probably, but 2 cylinders of similar ratio between their lengths. Their lengths of their, I don't know, but it's probably radii. Yeah. So it's linear. So that's just flat 3-to-4. And so you're going to square them to get area. Try the rest. You got this. Easy peasy. Have a great day.